Hello, I'm Neil Blecherman, Marketing Director at Supermicro. Welcome to Supermicro's 5G Live Forum and this panel discussion covering Intel Smart Edge technology and the Converged Edge Reference Architecture, or CERA. In this 30-minute session, we will hear from Bob Pike, General Manager, Intel Smart Edge at Intel, and Mory Lin, Senior Director, Worldwide IoT and Embedded Products at Supermicro. After their presentations, we will hold a live panel discussion with Bob and Mory. Please submit your questions in the BrightTalk platform at any time. And now let's hear about Smart Edge and CERA from Bob and Mory.
Thank you, Neil. Hi, everyone. Welcome to Supermicro 5G Live Forum breakout session, Smart Edge and CERA for Advanced MEC. I think first of all, in this 5G Live Forum session, lots of technology has been highlighted. But one of the key things we have to also make sure we can connect it well is the edge reference architectures. And this converge the concept here for the CERA. It's good designed to taking care of the on-premise devices. And also for sure, the outdoor highlight for the IoT also become a very key application, need to be monitored and support. It cannot be just like the general indoor server designed. So because of this, Intel brought a very good reference architectures for vendor Supermicros to work with. And then the session here, I would like to share what we invest here on the edge hardware platforms, and also the design know-how, how we work with the edge environment cohesively. And after that, Bob will share about the commercial deployment, about the Intel Smart Edge, and also from their perspective, where the markets will need parties work together. In front of you here, connecting the intelligent world from devices to the cloud, there are many components. I just put a simple chart here in front of you. From cloud and edge perspective here, they have a very different design requirement. Inside the data center, cloud architectures, it's talk about high density, high power, and high performance. But when you're getting closer and closer to the edge, there are many things need to be connected together. We use a 5G forum to become an angle to analysis these architectures for you. Inside the cloud architectures, there are lots of orchestration has been deployed. But when you're getting closer to the cell site, you will see the core network need to be managed. The radio access network need to be deployed. And for sure, those devices bring the computing performance to the edge, also need to have an aggregate server help them to bring the data for analysis. Therefore, in front of you here, you can see there are some light blue blocks here. It means those architecture could be the software defined, supported. And for the gray color here, so far still have a lot of proprietary hardware need to be deployed there to keep all things connected together. So it's a hybrid mode. This is the first concept let you feel like the converge actually is happening around us. Because of this, Supermicro brought several choices to the industry. You can see the network core computing here, lots of the high-density multi-node GPU type of design. When you extend to the radio access network area, the system getting smaller, but the performance inside, the requirements still pretty high because of virtualization, security, lots of things need to be managed, and those workload also need to be optimized. Therefore, the Intel FPGA and also other accelerators for VPU, GPU become a critical component need to be combined. After all these things combined together, there are a few things we want to let you know the investments we want to support you. First one is about the environment for outdoor. So as you can see, the machine is not a typical one, the rack mount device. It's a pole mount device. And this pole mount device allows you to deploy this machine to the outdoor area. We have several key engagements for the border controls and also for the facilities monitorings and for sure traffic control and so on and so forth. Those kind of things, they will require the x86 general platforms, but with the computing powers inside. After this, you can see indoor and also control environment still the mainstream for the deployments. We also have a lots of choice for you. And because all this possibility together, we also looking for a very good platform to onboarding lots of things. And that's why CERA and also Intel Smart Edge become a very good examples to share with you. Before we go to that applications, there are a few components I would like to continue break down for you to take a look. For the intelligent edge computing architectures, it's not necessary everything's inside the high computing telco network. But when things use spectrum, put it wider, you will realize actually lots of things happen also to the edge side. For the edge computing there, you will encounter lots of challenge because the customers might facing an environment doesn't have too much a tolerance for the operating temperatures. They need to keep it a high temperature for the heat. And also they need to reduce the fan because the environment might have lots of dust. We thought about it, and we also give the offering solution to the industry. But one thing we do different than other vendors, we put the Z-on-D performance still stay here. It matters because when you have so many orchestration idea want to onboarding to these platforms, performance is the first index. If it's not powerful enough, you still need to keep all those things inside the cloud. And we're talking about edge and also the computing to help the converge infrastructures, then performance will be the key. Because of this, 5G released the performance. And then the Open Radio Access Network bring the values to let these connectivities all synced. And multi-access edge computing, SD-WAN and UCP, is just one example allow you to quickly realize this is a commercial deployment. Inside this triangle here, there are many factors. Few things we want to share with you. The platform need to be opened. Open not just on the hardware, also the orchestrations for the engines, management features. For sure, scalable architecture is also very important. Scalable on the hardware for you to put accelerators in. Scalable on the orchestration layer allow you to put lots of virtual machine on top of that. And we cannot compromise virtualization's efficiency and also about security control. So all these factors are very important inside these intelligent edge computing architectures. And it's still not enough because we still need to handle lots of things behind this concept. Therefore, we want to bring one of the reference architecture here with you. Intel share lots of the design know-how with us. So the first step is Intel select solution on the universal customer premises equipment design. In this case here, what we are doing is because when the software partners want to put lots of ideas on top of general platforms, they encounter lots of issues. They have to make sure all their machine remote management securely, and also they can talk to each other efficiently. So deployment for the zero-touch provisioning, it's one key ideas have to realize. Otherwise, data center actually is much efficient architectures. The second thing is it's because of the age, so you are not able to manage them in the one single locations. Your remote features, your asset monitorings, and also the security control level, actually it's similar, probably much higher than what you control inside data center. You need to make sure the vulnerabilities will not be compromised. And also lots of environments, if you don't have enough data center level protection, your device actually, you need to have lots of last call features to call for help when the system encounters some issues. And also you need to keep it simple design because it's an edge contact, so you cannot make it too complicated. Therefore, in front of you, there are several small 1U box. And also 1U server allow you to put many accelerators inside. Those are certified with the Intel Select Solution UCPE, and also has been selected by several SD-WAN software vendor deployed. In this concept here, as you can see, the NFVI hardware here, Intel and Supermicro work together here. We put the Z-on-D, we put the lots of 10G network connectivities, we put the N3000's FPGA all together as NFVI platforms here. And we also select one of the partner, Adva here. They brought the edge cloud controller here to create assemble connectors. This allows lots of the VNF functions on top of this, including the virtual firewall, virtual router, and also there are lots of things that are ongoing on top of this. And to make this all possible, there are many layers need to be stacking together. So that's why SD-WAN, the chart here, you can see the branch office, they have a small, medium, large, different user base. And that's why you can see the box and the computing performance also scale up and down easily. They are not just scaling their performance through SD-WAN. They also need to scale up and down about their virtual machines and also for sure their hardwares. And combine all this together, we done the first steps. put the right Intel chipset into the Supermicro hardware. But what about the rest of the engines? You need to connect it together. And I believe Bob is going to share more deep dive here with you. Bob, at your side.
Yeah, thanks, Mory. I'm going to kind of add a few thoughts to Mory's comments here. When you look at this slide, the Intel Smart Edge team is kind of a commercial implementation of the ideas that Mory's sharing with you. And it's been exciting for us to work with Supermicro on some real commercial deployments. So where I'm going to focus in the discussion is the blue box that has the, let's say, bolded kind of square around it. Supermicro and Intel and CERA and OpenNESS and other parts of Intel support the network edge, your traditional cloud deployment, but where Smart Edge and Supermicro have worked together is the on-premise, specifically focused on commercial or enterprise deployments. And it's exciting for us both because it's an opportunity for us to begin to take this new converged world and find ways to monetize it. And really, that at the end of the day, that's what matters here. And to just leverage off of some of the things that Mory said, we are, if you think about these endpoints on the left, it really is about allowing the endpoints that are on the left and the industries articulated on the left to be able to deliver use cases in a new place, right, in a new converged way. So, Mory, if you could advance the slide, we're going to continue on this journey about the premise edge. So, Smart Edge is an implementation of the Converged Edge Reference Architecture. Our vision was to combine, as we have in the cloud, all these workloads into one Supermicro x86 box. So it is both the VNF elements, inclusive of WAN connectivity, all the way up through to, as you can see on the far right, access methods. It's supportive of cloud connectors. But as you look at the CERA reference architecture, you can move from a UCPE framework all the way over to the right toward more of a, let's say, truly layer 1 through 7 converged state. Now, when this really gets exciting for an enterprise is when they really can implement some of their microservices at the edge in the same box, one hop away from an access method. So we're going to get a little bit more into the detail out of that, but we've worked with Supermicro and leveraging the CERA architecture, our reference architecture, to build a commercial offering that we're kind of dig into a good bit deeper on the next slide. So if you could advance that more, that'd be wonderful. So we're going to spend some time on this slide, and maybe more you can chime in a little bit on this, is that I want to start. This is the architecture slide that we use when we're typically kind of communicating with a customer. This is the architecture that is being deployed in live commercial environments now. And I'll start from the left to the right. I think most folks know that there are connected devices that connect. You saw a better slide of that and better picture of that earlier. And then we have, our access methods. That's the LTE network or a Wi-Fi based network. We also support tethered access on the left. And then this particular box here with the orange and the blue in it, that is the on-premise edge node. So that particular asset is what I'm going to dig into most of all, but I want to kind of make sure you get the whole picture. So picture this is sitting on site. It's in a hospital, at a rail yard, in a retail store, behind a DAS, a small cell. It could be just behind a Wi-Fi network. But it is co-located there on premise. There's also in the software architecture, there is a controlling element. Traditional in a 3GPP deployment, you're using cups, which puts the user plane at the edge, and then the control plane is centrally. That also is mirrored in the enterprise environment, where they're using SDN. They'll have centralized control with the user plane sitting on-prem. This kind of gives you a better architecture from a management as Mory was saying earlier, orchestration, all those things become, let's say, simpler and easier to manage in this kind of distributed control and user plane. So there is software that runs in a cloud or a data center, or in a private or public cloud, that supports these management of many edge nodes to one, right? So there's one controller can support thousands of edge nodes, and that's not atypical in an operator's network. When we looked at the platform, one thing that we decided is that we would be extensible to the LTE elements as well as the VNFs. So the platform has been built that it is agnostic to those elements. Now, we all know all LTE data planes aren't implemented equally, so there's work to do in that space, but it is something that was contemplated in the design. As we look at deploying these on premise, we also realize that folks use different radios, they use different Wi-Fi networks. And when you looked at the original slides back there, a lot of the work in making this real really comes down to getting in the field and beginning to do implementations behind real radios, behind real Wi-Fi, and experiencing, like, let's say, what are the things that have to be in place in order for this to be simply deployed, managed by the operator, as well as friendly to the enterprise so that it can be consumed and considered trusted. I know some of the things that we're looking at now with Supermicro and others is what does redundancy look like in this, how do we leverage hardware and redundancy? So it's an exciting time for all of us because we're beginning to really experience what it's like to deliver a converged reference architecture at the edge. So what I'm going to do now is kind of go into the Supermicro edge node box and talk a little bit more about what is in the edge node. We do start with an Intel x86. We do have different sizes we've leveraged. This is where the assets of Supermicro become in handy. We have t-shirt size of small, medium, and large. But as a part of the platform, we leverage a lot of silicon in the security. So at a very pragmatic level, we want things like key management, secure tunneling with things like IPsec. We leverage QAT, TPM. I know there's a wonderful new offering coming out from Intel called SGX that we're looking in the secure enclave. If you think about the edge, one thing I would think about is you can't think about security in hindsight, because if you do, it's just more difficult to layer it in and you'll add cost. I would suggest when you're thinking about your premise edge, you think about security almost first because the threat vectors are more numerous. And this is where it's important that the silicon and the hardware platform, the BIOS and firmware, all of that is critical to this because you want to make sure you've protected against all those different threat vectors. As we move up the stack, we are layered on a Linux operating environment that really we're trying to get to the kind of, let's say, performance that's expected out of 5G. Up the stack, you can see now we're getting into, we'll have various VNFs that run there. This is in this blue in the bottom is where your LTE data plane would work. It is where, there would be some routing and switching capabilities. And then also if you have a guest VNF such as SD-WAN, that's the segment where you would run. When we contemplated the edge node, there was a requirement we did get out of a few operators that they wanted to think about the converged space from a support perspective. In a physical environment, you can go out and put a wiretap on something and do diagnosis. In this environment, it's converged. So we've given a lot of thought to the idea of operationalizing this. So you think about how do you get visibility to the packet flow in this converged state? So we put the span port in so that you can get a virtual tap, and there's a lot of security wrapped around this, so you make sure you're not looking at something you shouldn't. But it's definitely an area where we gave a lot of thought, and I would suggest you give a lot of thought to the operationalizing this, because you have to be able to support it. You have to see what's going on. You have to be able to refresh it. We often wait till the end to talk to operations and security. in this day and age, in this converged space, it's better almost to pull them in initially. So think about, we're at layers 1 through 3. Now we're beginning to deliver on top of the same box, layers 4 through 7 applications. Now you can redirect to those applications to that edge breakout port you see on there, or in certain instances in a smaller site, and this is where we work with Supermicro, you can have them all running on one box. So you can have, containers and VMs, and, if you're talking a retail store, that makes sense. Now, if you're talking a big hospital or industrial plant, multiple servers make a ton of sense around it. But as you can see in this is truly converged. This is going to deliver a couple of things to the market. One, it's going to help from a cost perspective. And more importantly, think about when you're implementing a new use case. The policy around it can marry networking, access, and the applications together in kind of a single policy framework. That is powerful, and it allows for more quickly delivering new use case, new applications, running at the edge of the network. Just as some help to the folks in the meeting, if you're working on your own platforms, or you're beginning to look at how you're working with Supermicro on this deployment, give consideration to the simplification of how this platform is viewed and the services that are added on it from an enterprise point of view. It is part of the journey that's the most interesting to us now. There's a lot of feedback that we're getting in on, hey, in an enterprise, they want to stay working like they're working. They don't want to change. The operators, same thing. They don't want to change. And really, it's very pragmatic. That kind of change is costly. So part of what we're working on is really, how do we simplify the consumption of this? And so some of the references that were made earlier in the Mano, all the different elements associated with the operator facing side, you've got to make sure what you built feeds into that in a way that's let's say symbiotic with it. Same thing on the enterprise side. From a controller perspective, we do suggest there's different ways to doing controller and managing your edge nodes. We picked a way that's a little bit more holistic because that was the requirements we initially got from the clients as to, hey, we need something that kind of packages this. But what this is a picture of, and what I just described, is the power of all those ideas that Mory really shared with you about delivering a commercial solution at the edge. Now, the last thing I want to layer out is, you see on the slide, healthcare, transportation, manufacturing, industrial, and retail. Now, we are just underneath 100 ISVs that we've been working with in this state. What we've learned is it's not about picking individual ISVs or use cases or trying to find that killer use case. Really what this is about is allowing your clients to be able to consume this in a way that they're already used to and using what they already own, because they already have a lot of assets and software relationships that are there. So the industry, I think, will do itself well if we are more friendly to allowing some flexibility from the workloads that are running there, create the security necessary to allow that to happen, create the hardware boundaries, right? So it doesn't affect any of the networking elements. But then you begin to get the momentum in the market, because you'll get the creativity of the whole industry around it, because they can now use it in a way that is more symbiotic to the way that they're used to. So I wanted to make sure I spent some time on an example and we do have deployments in all 4 of those industries. I would say that probably the one that's the least, let's say, the most challenging from a standpoint of moving quickly is the healthcare. We also have a good bit of government opportunities. I would say Intel does a really good job from a standpoint of securing this platform. Working with Supermicro, there's tons of things that I think we can do at the premise edge together. And then, back to any of the other partners here who are using a CERA reference architecture, hopefully some of the ideas that I've thrown out can be helpful. So, Mory, do you have any comments on this? I think, you did a great job of setting the table, and I wanted to at least share some specifics around the platform.
Thank you, Bob. So actually, I think this is a very, very nice and also comprehensive sharings. And this is just one echo back to the lots of the tier one carriers after they realized that Intel have such a power so many things on top of this. So I just want to let audience have one story from one tier one customer sharing. They said in the past, they have a lots of troubles, have to handle the expense to hire lots of IT people need to take care of the on-site devices. But now the biggest challenge after virtualization, they realized virtualization is beautiful. But the problems come after is how to manage them efficiently for those virtual machines. So autonomous orchestration become a key. And Intel makes sure those components will be securely managed and updated. That's the reason why when Bob talked about those things, we all know all the application already there for a while. But when you want to moving from proprietary design to the open architectures, software-defined environment, then lots of components need to be tested. And that's why the Intel give us lots of guidance to make sure when we design the chipset, all the way validate to the top connectivities from the firmware all the way up to the output for the network package. All things are combined. That's why you can see the red highlight here about IPsec. And also another carrier mentioned in the past, they probably need to update thousands of units monthly based. But the challenge right now is changed to daily. And update is not an issue as long as the manpower orchestration. But the problem is that secure? So that's why Intel committed to these topics to make this edge possible all the way from the cloud to the edge. It's easy to talk about data center security. What about those things like I mentioned in hospitals, in the retail space, the area near you every day? So they need to have the same level controls like they have inside data center. And to make all this possible, it's not easy, but it's doable. And now it's a commercial deployment in front of you. So once again, I think it's a very good sharing from both sides. And Neil, we'll pass the session back to you.
Thanks, guys. This was really very interesting and very thorough, and we're going to open up now for questions and answers.
At Supermicro, we have with us Bob Pike, the General Manager of Intel Smart Edge, and Mory Lin, the Senior Director of Worldwide IoT and Embedded Products at Supermicro. Guys, I really liked the way you played off of each other. Mory discussing the delivery of a commercial solution at the edge, and Bob talking about operationalizing that deployment and the customer experience. If we could start, Bob, with a question for you. If a customer wants to deploy a Supermicro solution with CERA and Smart Edge, where do they start?
Well, great question. There's a lot of interest right now, so we want to be very clear about this. CERA on-premise is a pre-validated reference architecture, with hardware and software optimizations. And Supermicro is the hardware vendor for CERA. And Supermicro works with certain ISVs and systems integrators to pull together a complete solution. Intel Smart Edge is the commercial software, that hardware and software that was discussed about CERA on-premise. We're the software piece of it. That is combined with the Supermicro platform with these systems integrators. For example, some like Pivot, there are quite a few of them out there that Supermicro leverages to help them bring this to market.
That's great. Thank you for painting that picture for us. Mory, how about a question for you? Please give an example of a vertical market deployment of Smart Edge on Supermicro that you think was really done well and why you think it was done well.
Thank you, Neil. I think, first of all, in this SD-WAN deployment is the real application. It's called the software-defined wide area network. Inside this combination here, UCP is the hardware being considered. So in this combination here, there are several factors has been combined together here. First of all, performance need to be high enough. And then that's why Xeon D, this Intel technology, give the chance bring everything together into a small footprint box. And after this design here, there are several things we also add into it. For example, like the data center performance on the networking connectivities, we bring the 10G interface to help the edge. And this SD-WAN, the UCP business, the real application customer they're using right now, they're using the scalabilities to adjust the bandwidth based on the branch office users. For instance, like I understand the COVID-19 created a big impact to the retail industry. But before the COVID-19, lots of deployment right now, they're asking for an edge computing box, able to upload and download lots of data. And those things will help them to make their retail space safer for the virtual router and also make their retail space smarter because of the inventory information will be shared intelligently. And those things, it's easy, just a standalone device, but because of this design, it's allowed the CERA with the Intel Smart Edge concept bring all those applications all together. And we believe this continued journey here will need more investment. And after the COVID-19, I believe when we're back to the real life, the people start to think about how to get the right products out of the shop immediately. And I believe this will change lots of the consumer behavior. And we need to lay the foundation there first for them. Thank you, Neil.
That's great. Retail is a really good example. Thank you. There's another question that I see on the screen, and please, if you're in the audience and you're watching, please feel free to submit more questions. Here's the question. So are there any pros and cons on edge computing economics compared to similar cloud-based computing? And the writer also says, if you set aside performance and latency issues. So Bob, would you like to address this first, pros and cons?
Well, it really comes down to, well, there's several sides of this. One that we've run into really has to do with the backhaul or the WAN traffic. If most of the content is created local and then consumed local, at a certain point, physics takes over and it just doesn't make sense to send it back upstream and bring it back. Now, I will say, we really don't try to debate where the workload should go. It usually is pretty logical where that should occur. We're really looking at more of an experience enhancement. Now, latency is a part of that. So it really comes down to the business case. The other piece that I think we didn't expect was there's a lot of operating technologies that exist on premise in certain industries. The four we're working in there definitely are. So the kind of integration with those operating technologies and then sharing that information east-west with, I guess, the various opportunistic use cases that are more at the edge, really it becomes business case driven. If you can't make it work financially or operationally, then it doesn't fly. We haven't had a hard time determining that. It really has been pretty logical for us to this point. I think it will get more prescriptive as we go along.
So, Mory, in the minute we have left, did you want to add something to that?
Yes. From our observations to the edge computing, performance and latency was just a starting point. And actually, on edge computing, there are lots of things about how the user behaviors responds to those computing power they got. And what does that mean? Think about when you have a lot of the data need to collect through different sensors, through camera, through voice recorders. And also how to make those message can be communicated different machine to machine, vehicle to everything, or to the administrations people to know how to deliver you the right predictive actions back to the people in the scenario. So those things are not necessary about just latency and performance. It's actually the scenario will that make their life better. And that's the reason why telematics and other things. Recently, the edge computing, not just about retail. I think Bob highlighted about several very important infrastructures they are using this, such as manufacturing industry here, and also healthcare. Those things will rely on lots of the solution designed for the user's environment. So to make this possible, people need to get the real-time response. And performance and latency is just one of the index we need to deliver. But actually, people expecting more than that. They want to feel there's nothing they have to worry about performance and latency. They just need a real response to secure their problems at edge side.
Thank you guys for this wonderful conversation. And please, everybody, have a great day.
Stay safe.
Stay safe.
Thank you.
Bye now.